On today's lesson in periodic perfection, we're going to be learning about ions. What are ions? How do they form? What are they for? How are they different from atoms? Are they positive? Are they negative? What's going on? So let's do a deep dive into ions. Let's go. We can't talk about ions without discussing ionization energy. Ionization energy is the amount of energy required to remove the most loosely bound electron from a neutral atom in its gas form. Essentially, you can think about it as how much energy it takes to steal one of an atom's valence electrons. We sometimes refer to this as first ionization energy, and that is the way it appears on Table S on your reference table. The higher the ionization energy, the more the atom holds on to its electrons, the more tightly it holds on to its electrons. You can kind of imagine it like a purse snatcher trying to steal a bag from Wonder Woman, which would have very high ionization energy. She'd be holding on to that bag pretty tightly. Or a purse snatcher trying to steal a bag from, I don't know, me? I'm not very strong. Wouldn't hold on to it very well. Say goodbye to my wallet. But the higher the ionization energy, the more the atom holds on to its electrons. It's measured in kilojoules per mole. Okay, so that's how you're going to see it on Table S. So let's try a little something with this. Which element holds on to its electrons more tightly? Francium or fluorine? Well, we're going to need to go to Table S and look up the first ionization energy for these two elements to be able to solve this problem. If you did this, you probably found that francium has a first ionization energy of 393 kilojoules per mole, while fluorine's first ionization energy is 1,681 kilojoules per mole. That means that fluorine is holding on to its electrons just like me holding on to my coffee in the morning. I am not letting it go. Whereas francium, it could take it or leave it. Its electrons, you want them, you take them. Let's try another one. Which element loses its electrons more readily? Magnesium or sodium? So once again, go to Table S. When in doubt, get your S table out. So magnesium has a first ionization energy of 738 kilojoules per mole, while sodium's is 496. Because sodium's first ionization energy is lower than that of magnesium, it means sodium will lose its electrons more readily. In fact, sodium practically is just giving them away. Before we move on, we need to just do a quick little recap on atomic structure. Remember, atoms differ by their number of protons. If you change the protons in an atom, you no longer have the same element. You have something new. Ions differ by their number of electrons. This is a little bit different. Now we're going to be adding in or removing electrons from an atom in order to form an ion. Isotopes differ by their number of neutrons. If we take an existing atom, add a neutron to it, we have formed a new isotope for that atom. You don't change the identity of an element simply by adding or subtracting neutrons from its structure. You just make a new isotope. How do these ions happen? And let's get into some terminology, because there is a little bit of very specific vocabulary that we have to dive into when we're talking about ions. So first off, ions are charged atoms or groups of atoms. So an ion can be a single atom with a positive or negative charge, or it can be a group of bonded atoms with an overall negative or positive charge. These are known as polyatomic ions, and you're going to find those on Table E of your reference table. We're going to be using those an awful lot this year in chemistry. Ions have an unequal number of protons and electrons. Now remember, since we cannot change the number of protons, that means we must be changing our electrons. The charge is usually the difference between the protons and the electrons. So remember, protons are positive, electrons are negative. This means that if we add electrons, we will be gaining an overall negative charge for our ion. If we lose electrons, we will be getting an overall positive charge for our ion. We can never change the number of protons. Now, the charge isn't just about the overall positive or negativeness. It does have a magnitude. We need to know exactly how positive something is or exactly how negative something is. This is going to be very important. If there are more protons than electrons, our ion will be positive. And if there are more electrons than protons, our ion will be negative. Let's get into that terminology. Ions can be either negative ions or positive ions. Negative ions are specifically called anions, where positive ions are specifically called cations. Now, an ion in general is any charged atom. If we're talking about negative anions, we always have more electrons than we have protons. And in the case of a positive ion, we always have more protons than we have electrons. Remember, once again, we cannot change our number of protons. This is all about shifting around our electrons. Anions are formed when we gain electrons. Cations, on the other hand, are formed when we lose electrons. So anions are negative, cations are positive. Now, there are a couple ways to remember this. Let's start with anions. When I think that an anion is a negative ion, anions are negative ions. Negative ions. Anions are negative ions. An ion, a negative ion. So there's one way to remember it. Anions are negative. Cations, on the other hand, when I see a cation, I see a positive ion. I see a positive ion. That is, I see a positive ion. Get it? Now, there's another way to remember this, and it's kind of personal to me. I mean, if you know me, you've seen any of my other videos, you know I've got a couple of cats. Does Ms. Knoll like cats? Yes, she does. I'm positive. Or, did you lose an electron? I did. That leaves me positive. Or, cats are the cutest ions. Are you sure? Yeah, I'm positive. That was super disturbing. I'm sorry, guys. I'll try not to do that again. No guarantees, though. So oxidation. This is the way that we form ions along with reduction. They're two processes. They're kind of the opposite of one another. When an atom loses electrons, it goes through oxidation. The ions that are made are always going to be smaller than the original atom when we have oxidation occurring. Metals tend to lose their electrons or be oxidized, and this is what happens when iron rusts. That is all oxidation. It's a chemical process. It's super important. So when we form a cation, let's use sodium as an example. Sodium's a metal. It's in group 1. It has 11 protons, and it normally has 11 electrons. It has 2 electrons in the first orbital, 8 in the next, and 1 all alone in its valence shell. So when it forms a cation, it's this electron in the valence shell that it's going to tend to lose. So that electron goes away. We're losing 1 valence electron, and we are going to form a sodium ion with a positive charge. And in fact, it is a positive 1 charge because it lost 1 negative electron. Very important to remember here that the positiveness of a proton is the exact same magnitude as the negativeness of an electron, and that's why they're a 1-for-1 balance. So the sodium ion, when it loses that electron, it actually loses an entire shell. And that's why it's getting smaller. So that is oxidation. Now let's look at reduction. Reduction is the opposite of oxidation. So if oxidation is losing electrons, reduction would be gaining them. Excellent. So this is when an atom gains an electron. Ions that are formed through reduction will be larger than the original atom when they are reduced because of something called electron repulsion that we'll talk about in just a moment. Nonmetals tend to gain electrons or be reduced. Here's an example of that. Chlorine. Chlorine has 17 protons. It's atomic number 17. That means that it has 2 electrons in its first shell, 8 in its next, and 7 in its valence shell, which means, as we've discussed, 7 is not the magic number. What is the magic number? It is 8. It wants that octet of electrons. So it's going to do that by gaining 1 electron. So here out in space is that electron that we're going to gain. It comes in and fills that spot in our last orbital, giving it 8, and it forms a chloride ion, and that's a gain of 1 valence electron, giving chloride a charge of 1 minus. Okay, 1 negative charge on a chlorine. So for example, let's look at a lithium atom. A lithium atom has 3 protons, 3 electrons. The thing about ions is they're always trying to get to the same electron configuration as a noble gas. They want 8. Now lithium doesn't need 8, it only needs 2 because the one it wants to be like is helium, but you're going to see this. So it's going to lose 1 electron and it's going to become 3 protons and 2 electrons, giving it an overall positive charge. So lithium is a 1 plus ion. The lithium atom would rather be a lithium ion because then it has 2 valence electrons that have been exposed in that shell, that first orbital, that make it stable like helium. Sodium, on the other hand, with its 11 protons and 11 electrons, also wants to be like a noble gas. If it loses 1 electron, it now has 10, but that is 2 in the first shell and 8 in the second, and that makes it a sodium ion. Once again, it would rather be a plus 1 ion or a 1 plus ion in order to have its stable octet. Now let's talk a little bit about naming ions. Not complicated, super easy. So if you have a cation, which is positive, we use the element name and then we say ion. Now your cations are almost always going to be formed from metals. So for example, in this first one, that's a calcium. Next is cesium and last is aluminum. So this would be a calcium ion. Next we would have a cesium ion. What would the name on this last example be? Well, that would be an aluminum ion. Get the idea? But now when we go to anions, the rule is going to change. Anions, we name them by changing the ending of the element name to "ide" and then saying ion. So for example, with sulfur here with a 2 minus charge, that would no longer be sulfur, it would become a sulfide ion. Next we have phosphorus. With its 3 negative charge, that would be a phosphide ion. What would our next one be? Well, if you said a nitride ion, that's great. What about our oxygen? What's going to happen there? That's going to become an oxide ion. And lastly, chlorine, that will become a chloride ion. See how that works? Once again, metals will be the name of the element followed by ion, and nonmetals or anions will get the "ide" ending and the word ion. So if we look at some various ions, over here on the left side of our periodic table in groups 1 or 2, we have some metals. Notice the group number tells you the type of ion it is going to form. For example, lithium, group 1, will form a 1 plus ion. Beryllium in group 2 will form a 2 plus ion. Now, our transition metals, remember, they're little wonky groups 2 through 12, or sorry, 3 through 12, they don't really follow the rules. We're going to get to them later. They're special. Yeah, they need special treatment. All those transition metals, all trying to be extra. Here in group 3 or 13, depending on the periodic table you're looking at, you have aluminum here with a 3 plus. Then when we remember, that's a metal. That's why they're going to be positive. They're going to lose electrons. When we get over here to our non-metals in group 7 or 17 and 16, we are gaining electrons, and so we are forming negative charges. You get no ions in group 18, and that is once again because they are noble gases. They do not react with anything. So let's try a couple of problems. I want you to give me the following information for a chloride ion with a 1- charge. Give me the electron configuration of this ion, the Bohr diagram for the ion, the Lewis structure for the ion, and tell me, is this ion going to be smaller or larger than the atom? So the ion electron configuration for the chloride ion is going to be 2-8-8 because it is going to be gaining an electron. In your Bohr diagram for that ion, you would still show 17 protons and 18 neutrons, and then on our orbitals you would show one level with 2, the next with 8, and the last with 8. Now normally chlorine has 7, but remember it has gained an electron. Our Lewis dot structure in this case would be our Cl for our kernel surrounded by 8 dots for our electrons, but in an ion Lewis dot we have to draw it a little bit differently. We put brackets around the ion that we are drawing. That bracket shows us that it is an ion. We also include the charge of 1-. So it's going to look something like this. Will that ion be larger or smaller than the atom it came from? Well, it's going to be larger because we are gaining electrons. Let's try example 28. What type of energy is represented by the energy in this equation? So here we have potassium with a charge of 0 plus energy becoming potassium with a 1+ charge and an electron with a -1 charge. If you said that energy is the ionization energy or the first ionization energy, you would be correct. What we are showing here is the formation of a potassium cation. So let's look at example 29. Let's say we have a nitrogen that only gains 2 electrons. Now normally nitrogen will gain 3. In this case, let's say it only gains 2. Will that be oxidation or would that be reduction? Well, if we are gaining electrons, then we have reduction. My next question to you is, how would we write the ion for this nitrogen? Well, that's going to look something like this, N2-. Because its ionic form, it is gaining 2 electrons that is going to give it an overall negative charge. Its electron configuration would be 2-7. Now, would this ion be its most stable form of ion? If you said no, you're completely correct because we're not yet at that full octet. Nitrogen is going to want to gain 3 electrons in order to form that. Let's try example 30. Let's say a carbon loses 3 electrons. Would that be oxidation or would that be reduction? Well, that would be oxidation. How would we write the ionic form for this carbon if it is losing 3 electrons? That would form carbon 3+ because we have lost 3 negative charges. You can kind of think about it like this. If I'm having a really bad day and I call up my best friend and I vent to them and I unload all my negativity on them, I feel better because I've lost some negativity. I'm more positive now. Yes, the electron configuration for this carbon would be 2-1 because it has lost 3 electrons. Would this be its most stable isotope? Absolutely not. Carbon generally has 4 electrons in its valence level, so just having 1 actually makes it less stable. How many electrons would each of these ions have? If we had bromine with a 3- charge, how many electrons would it have? Well, normally bromine has 35 electrons. If we're gaining 3 more, now it's going to have 38. What about lithium with a 1+ charge? Well, normally lithium has 3 electrons. If it loses 1, which is what's happening here, now it's only going to have 2. What about iron with a 3+ charge? Well, if we have an iron ion with a 3+ charge, normally iron has 26 electrons. If we have a charge of 3+, that means that we now have 23 electrons. Let's try one more problem. What is the net or total overall charge if there are 10 electrons, 11 protons, and 12 neutrons in an atom? The net charge for this atom, we only need to look at the electrons and the protons. Remember, neutrons are neutral. We have 1 more proton than we have electrons. That means the net charge would be +1. The next question asks, what is the nuclear charge of this atom? Nucleus? What's in the nucleus? It's only your protons and neutrons. So our nuclear charge would be equal only to the charge of the protons. So the nuclear charge of this ion would be 11. So this is an ion with a net charge of 1 positive and a nuclear charge of 11. So that's been our exploration of ions, where they come from, what they are, how we make them, how we name them, and how you can remember which are which. On our next lesson on periodic perfection, we're going to be diving into some atomic review, and then after that, I'll be introducing you to the mysteries of the periodic table. Thanks.